Okay, continuing with our review on similar triangles, here is part 2. So which triangle is similar by side, side, side? Well, these are not congruent, but we can still use side, side, side if they are in proportion. So it looks to me as if this is the shortest side for this triangle, and this is the shortest side for this triangle. So what I want to do is to see if the proportion 4:8 is the same as this is the next shortest side, this is the next shortest side as 6:12, and finally this is the longest side. So if these proportions are all true, then the triangles are similar, and the angles need to match up. So angle C is between the short and long side. So angle E has to be the same as angle C because they're the short and long side. Okay, so angle A has to match with the longest side and the middle side, or angle D. So these two angles are the same measure. So remember, the angles are the same measure and the lengths are in proportion. And of course you see that this means that the third side has to be the same as well. So ABC is going to be congruent to DFE. Sorry, similar to DFE. So it says that these two are similar. So measure of angle W must equal the measure of angle H. And the measure of angle U must equal the measure of angle F. So this, it would follow, is 76 degrees because the angles are the same measure in similar triangles. So again, these triangles are similar if they are in proportion. So the shortest side is 8, and the shortest side is 48. The middle side, or the one in the middle, is 14:72, and the longest is 12:84. So are these proportions true? Well, this one I can think of as reducing to 1/6. So what is 14 times 6? Oh, 14 times 6 is 84. Oh, I have these mixed up, don't I? Let's fix that. So this one is supposed to be the middle one, and this one is supposed to be the long one. So our proportion needs to be rewritten because I didn't have them paired up correctly. And you saw how I did that. So let's get back on track. So this one was supposed to be 12:84. And 14 is to 90. I think I'm doing it the same way I did it before. Let's fix that. So this one, 12, the one in the middle, has to go to 72. And 14 is to 84. So small, medium, large, small, medium, large. Okay, I think I've got it set up right now. So this is also going to reduce to 1/6, and this is going to reduce to 1/6. So these are similar by side, side, side. So that means that the angles have to match up. So if we start with 8 is to 48, so 8 has to go to this one, and H has to go to A, and F has to go to C. And that's just based on the triangles. So this is the short side, this is the short side, but to its right is the biggest side. And so angle F is between them. So angle ABC is congruent to angle HGF. So you have to match up the sides so that you can see the congruency. What is the measure of angle G for triangle TSH to be similar to angle FGH by AA? So angle, these two angles are vertical. So this one must be 80 degrees. And so this is going to be kind of a reflection over this line here. And so in order for those to be similar, this one has to be angle G, just based on the layout of the figure. So this one also has to be 61 degrees. Choose the pair of triangles that are similar by the side angle side theorem. Well, as you look at the triangle, you see that angle with 61 degrees and the angle with 61 degrees is going to work out. Kind of instinctively, you see that. But you also need to check the sides to see if they're in proportion, because otherwise these two might work. Okay, so let's not jump to any conclusions. Let's do some proportion checking. So 4 is to 8 and 5 is to 10 works out. But in this one, the 53-degree angle is between them, so it would have to go there. Okay, so those two aren't going to work. So we're thinking that it's these two. So let's check this one out. 3 is to 9, multiplied by 3, right? And 6 is to 18. Oh, again, multiplied by 3. And this angle is between them. So again, do check out the angle measures as well. But you can see that it is these two, because the sides are in proportion and the angle between them is the one that matches. Number 16, what fact would be sufficient to prove that triangles ABC and DBE are similar? And it would need for these two to be parallel. That would mean that this angle matches this angle, and this angle matches this angle, and this angle matches itself. So we would need to know that DE and AC are parallel. Number 17, which of the following statements must be true to prove that angle GHI is congruent to angle JKL? So two triangles must have exactly one acute angle. The word exactly means that they don't have to have, they should not have more, and so that wouldn't work for any triangle. The corresponding sides of the two triangles must be proportional. So that is a must. Two triangles must have exactly one obtuse angle. No, they don't have to be obtuse or acute in order to be congruent. To be similar. Two triangles must have exactly two congruent angles. The word exactly is the problem, because what about the third one? Exactly means that they have only two, no more, no less. So that one would be a problem. So 17 is going to be that second statement. Okay, move on to page 3. On page 3, we have this wonderful quadrilateral. XY VW. So we have that XY is parallel to VW. So remember, let's make our marks on there. Those are the little triangles showing you that these two are parallel. So we have these little triangles. So we've marked these parallel. And the diagonals intersect at Z. Which statements are true? Well, we are going to have similar triangles. They're not going to be congruent because it doesn't say anything about these being a midpoint. But they can be similar because this angle must equal this angle. And if you think of these as transversals, this angle must equal this angle. So they're going to kind of flip, right? Because these are alternately interior if this is my transversal. So XWZ, it doesn't really mean anything about that one. And YVZ, YVZ. So they're saying that this triangle is congruent to that triangle. And again, these angles are congruent, and these are alternate interior if this is a transversal. So that's definitely a possibility. Let's look at the other one. XYZ is congruent to VWZ. So what they're saying in the second statement is that this angle is congruent to this angle. So we don't know that these two are parallel or anything about them. So it does need to be the ones with the parallel sides. So it's definitely not this one. So this is the statement. Because these two lines are parallel, we know that this angle and this angle match. So it's XYZ, XYZ, and VW. Because this angle matches this angle. Again, we don't really know anything about these angles because of the transversal. Summary number 19. In the diagram below, SQ and PR intersect at T. PQ is drawn and PS is parallel to QR. So there's my parallel markings. Those two lines are parallel. So these two angles are congruent, and this angle matches this angle. So it's going to be angle, angle, side. Number 20. Let's stop this video and we'll put the other in a third piece.